So another important distribution in the exact sampling distribution is F distribution. So the F distribution plays a vital role in the ANOVA technique. So in the ANOVA experiment, we are depending upon the F statistic value. So that F statistic value gives us a more information regarding the experiment accuracy results or whatever it may be. So definition of F distribution is if X and Y are two independent chi-square variates. We know the chi-square variates. So chi-square variates V1 and V2 respectively. Then F statistic is X by V1 and Y by V2. So we have two independent chi-square variates, that is a that is a V1 and V2 with respect to of X and Y. So whenever if respective variables are division with by respect to chi-square variates, so automatically we will get a F statistical value. So in other words, we can say it is a F is defined as the ratio of two independent chi-square variates divided by respect to degrees of freedom. So whenever we have a two independent chi-square variates, is divided with a to respect to degrees of freedom, automatically we will get a F statistic value. So the F distribution have a probability density function. The curve looks like this. So the F distribution lies between 0 to infinity. See here the graph, identify the curve pattern. The curve is starting from here 0 to and stretched to the right side. So stretched to the right side. This right tail probability indicates with alpha. And also remaining region, this is we called as a F critical value region. So there is a similarity between the F and chi-square. See, observe that here. So chi-square graph is also similarly F distribution graph. Why? Because of this both distributions follows the limits 0 to infinity. If for example, if these two distributions the two distribution is tends to follows the normal distribution when the degrees of freedom is increased. For example, here observe here chi-square distribution degrees of freedom df means degrees of freedom is equals to 3. So if the degrees of freedom is equals to 3, the graph appears like this. For example, if these degrees of freedom increasing to the 5 or 6, maybe 7, whatever it may be, if whenever you increase the degrees of freedom, automatically the curve will be also changed. So maybe this curve will stretch into close to the normal distribution. So when it is possible, whenever our degrees of freedom is increased, automatically the curve will be changed, and also it is close to the normal distribution. Similar property, similar characteristic also have a F distribution. So that is the reason F distribution also a limits 0 to infinity. If you want the increase of the degrees of freedom, automatically it will also tends to the normal distribution. So these are the both similarities of the chi-square test and F distribution. And also so some of the properties we have F distribution. One is F distribution is belongs to the from 0 to infinity. I already told you. And also F distribution curve only lies the first quadrant. So in the graph, you can take any graph. In that graph quadrant, we have a 4 type of quadrants: first coordinate, second coordinate, third coordinate, fourth coordinate. So the F distribution is located graphically in the first coordinate. And also the shape of the curve of the depends of the F distribution mainly depends upon the degrees of freedom. So always, I already told you, if our degrees of freedom, degrees of freedom 1 or 2, the graph appears like this. Maybe if we want to change the degrees of freedom, automatically the graph also will be changed. It is also close to the normal distribution. So F distribution and also important properties, it is have a positive skewness. The curve, because of the curve is stretched from to the 0 to infinity, and also it is stretched right hand side. So whenever the curve is stretched more than more than part stretched right hand side, automatically that distribution have distribution exists as some of the skewness, which that skewness is positive skewness, and also the curve of the unimodel of the mode point of the up distribution is V2, F is equals to V2 into V1 minus by 2 by V2 plus 3. And also mean of the F distribution, V2 by V2 minus 2. And variance of the F distribution, 2V2 square into V1 plus V2 minus 2 by V1 into V2 minus 2, V2 square minus 4 for V2 greater than 4. So most important property in the F distribution is there is no kind of generating function, which means that moment generating function does not exist in the F distribution. It is a very, very important point. So mean of the F distribution is V2 by V2 minus 2, which is greater than V2 is greater than or equals to 3. And variance is 2V2 square into V1 plus V2 minus 2 by V1 into V2 minus 2 into V2 square minus 4, which is V2 greater than 4. So, and also main important point, the moment generating function does not exist in F distribution function. So we know that F distribution have a positive skewness. See why? Because of this graph here, starting from left hand side and stretch its more than part right hand side. So that is a reason we can say it is a positive skewness. Whenever our data, if for example our real-time data have a skewness, maybe positive or negative. For example, it follows that graph follows left hand side to right hand side, automatically it will be converted into the it will be converted into the skewness. And also the important point is moment generating function does not exist for the F distribution, and also applications of the F distribution. So we applications of the F distribution is for most important applications we have. One is F test for equality of two population variance. We can test the we can apply the F test in for checking equality of the population variance, and also testing the significance of the observed multiple correlation coefficient, and also we can test the significance of the observed sample correlation ratio, and also F test for testing linearity regression. So whenever our regression model is in a linear, we can testing through the F test, and also we can check the equality of several means. See, in this T distribution, we can compare with the student mean T distribution. Whenever our for example, if our data have so many variables, for example, if perform the and calculate the means more than one variable, we have to check the several means of the data at a time. We can use F distribution. So in ANOVA concept, F distribution plays a very crucial role. We know that ANOVA application application is in the almost we can use in the some design of experiments topics, and plots areas and yield. So many characteristics are available. So in that ANOVA technique, so F distribution plays a vital role. Whenever our F statistical value greater than 1, we can check with the table values whether it is a significant or not. Because of there is any difference between the several means or not, we can check at a time by using F distribution. So these are the very important distributions in the exact sampling distribution. We know that the first one is the chi-square distribution. The chi-square distribution of the main definition is whenever our standard normal variate is the square of the standard normal variate, automatically we will get the we will get the chi-square distribution. So chi-square distribution structure also a right hand side. It is also a right hand side. So that is a positive skewness exists, and the negative skew and same also coming to the mean of the this distribution is n, variance is 2n, and also moment generating function of the chi-square distribution is 1 minus 2t whole power minus n by 2, and which is have a positive skewness, and it follows leptokurtosis because of that beta 2 greater than 3. And also coming to the applications of the chi-square chi-square distribution is it is a goodness of it for testing the goodness of it, and testing the independence of attributes, and homogeneity of the independent of estimates of the population variance, and so many applications are we are using chi-square test. And another important is the student t distribution. So to student t distribution is follows normal. We know that the main definition of is t is equals to x bar minus mu by s by root n. So whenever student distribution follows the almost close to the normal distribution, and the mean of the student t distribution is always 0. So mean of the student t distribution is always 0, and odd moments are also 0. And even moments are exist. That is the reason mu4 is equals to 3n square by n minus 2 into n minus 4. This is the value of the fourth central moment of the student t distribution. And also student t distribution does not exist any type of skewness because of the it follows almost close to the 0. So that is the reason beta 1 is equals to 0. Here beta 1 equals to 0 means which means that options of this skewness we have. So that is the reason there is no skewness in the student t distribution. But beta 2 greater than 3, that is the reason it follows the leptokurtosis. And also whenever our standard Cauchy distribution, whenever student t distribution degrees of freedom reduced to the 2, n is equals to 2, automatically this distribution has been converted into the standard Cauchy distribution with 1 degrees of freedom. So these are the main applications of the student t distribution. And also student t distribution mainly using in the test the significance of difference between two sample means and population variance being equal or unknown. So whenever if we have our data in the two variables, so whenever you test the significance of the two difference of between the sample means, you can use the student t distribution. But here if you want to check the more than two sample means, whether they are following significance or not, that time we are using F distribution. So F distribution, major important of the F distribution is we can check a homogeneity of the several means at a time. So that is the reason F distribution have a more advantage, and a more important, better than the T distribution. So we know that the distribution of the F distribution of the definition. So we have two independent chi-square variates. It's divided with respect to degrees of freedom. Automatically we will get the F distribution. And also we know that the curve is stretched more than right hand side. It is also have a positive skewness, and also it is tends to 0 to infinity. It is lies in the first coordinate, and also shape of the curves depends upon the degrees of freedom. So these are the major important applications properties regarding the chi-square distribution and F distribution and student t distribution. Thank you.